Good day, everyone, and welcome to Ziegler Institute. For today, we have a particular question that we're going to be solving today. It's actually from JEE Advanced Mains, a particular exam that is designed for, I think, admission for engineering students in the country, India. So the question is actually a very straightforward question. So we just want to look at it. And I hope as we go through it, we'll be able to understand the question. So basically, that's the question there. And the question says, let f of x be a continuously differentiable function on the interval 0, infinity, such that they give us a condition there that f of 1 is equals to 2. And they gave us a limit as t tends to x, t to the power of 10 f of x minus x to the power of 10 f of t divided by t to the power of 9 minus x to the power of 9 equals 1. For each x greater than 0, then for all x greater than 0, we have f of x to be equal to what? So from those options there, we actually want to solve this question. So something to be continuously differentiable means that it has a derivative, and that particular derivative is also continuous, right? There are conditions for continuity. The first one is that the function must be defined. The second one is that it must have a limit, and definitely we talk about being continuous. And for something to be differentiable, it must satisfy the fact that it is defined, the fact that it has a limit, and the third one is that it must be continuous. Then you can actually say the function is differentiable. So we're going to be solving this question so I wouldn't waste time on it. So how do I approach this? So I'm going to write the limit out first. So my solution. So the limit is what I'm going to write out first. So I have the limit as t tends towards x of t to the power of 10 f of x minus x to the power of 10 f of t, all divided by t to the power of 9 minus x to the power of 9, then this is equals to 1. Very interesting question, so let's proceed. Now the first thing I'm going to do is that I observe that fixing my limit t tending equals x into this particular function will make the denominator equals to 0. And when that happens, it will make this whole function actually undefined. So for us to actually obtain the limit, what we're supposed to do is apply the L'Hospital's rule. And that rule is saying that I should differentiate the top and differentiate the bottom. But in this case, because I know that a function here is actually with respect to t, I'm going to be differentiating with respect to t. So I'm going to have something like this. If I differentiate this, I'm going to have with respect to t now, the limit as t tends towards x, t to the power of 10 becomes 10t to the power of 9 if you differentiate t. F of x will still remain as a constant value minus, then x to the power of 10 will remain because I'm differentiating with respect to t. Then the function f of t becomes the derivative of f of t. Then at the bottom, x to the power of 9 goes to 0 because it's serving as a constant value. So t to the power of 9 becomes 9t to the power of 8. And this should be equals to 1. So now I can easily fix in my limit as t tends towards x, meaning that anywhere I see t, I should fix in x. So I'll get something of this nature: 10 x to the power of 9 f of x minus x to the power of 10 f prime of x, because t now is x, divided by 9x to the power of 8 equals 1. So we'll continue solving, and we'll cross multiply. In this case, we have 10x to the power of 9 f of x minus x to the power of 10 f prime of x equals 9x to the power of 8. Now the next thing we're going to do now is that I can see that this particular expression looks like a differential equation. So what I'm going to do first is that I'm going to multiply it through by minus 1. So multiply by minus 1. I'm going to have my x to the power of 10 f prime of x minus 10x to the power of 9 f of x equals minus 9x to the power of 8. So the next thing I'm going to do is I'm going to divide through by x to the power of 10 to remove this from the derivative function here, f prime of x. So if I do that, I'll have the f prime of x equals, I have the f prime of x minus 10 over x, f of x, equals minus 9 over x squared. Meaning if you divide through by x to the power of 10, and try that on your own, you'll get what I'm saying. Now, this particular expression that you can see here, I'm going to call this equation 1, actually looks like a first order ordinary differential equation. So a first order ordinary differential equation looks like this. Let's take it for instance, maybe y is actually my f of x. Let's say y equals f of x. So I'm going to have the first order differential equation to be something like this: y plus, y prime plus p of x y equals q of x, is a representation of the first order differential equation, and has an integrating factor, where the integrating factor is actually the exponential of the integral of p of x dx. But the solution to this equation 2, which is the ordinary first order ordinary differential equation, the solution to is always y times the integrating factor equals the integral of q times the integrating factor, then plus c. So this is actually how I'm going to write my solution at the end of the day. So when I go back up to equation 1, I'm going to compare this equation 1 to equation 2 to bring out my p of x, that's the p, and also the q. So if I do that, I can see from here that my p is actually minus 10 over x, and my q is actually minus 9 over x squared, right? So once I do this, the next thing I'm going to do now is first of all get my integrating factor using this particular expression here. And what do I do? My integrating factor is the exponential of the integral. What is p initially? Let me write it here so we'll see clearly. P was actually minus 10 over x, and our q was actually minus 9 over x squared. So we can see it clearly here. So integral of minus 10 over x dx, and if I evaluate this, I have the exponential of minus integral of 10 over x dx, which eventually will become the exponential of minus 10 ln x, right? And eventually I have exponential of ln x to the power of minus 10, which becomes x to the power of minus 10, and that will give me 1 over x to the power of 10. So that's actually my integrating factor. Now I have my integrating factor. The next thing I will do is to use equation 3 to evaluate that particular ordinary differential equation we had. So I'm going to go up, so we'll see it again, this particular one from equation 1. So the solution is going to be y times the integrating factor equals the integral of q times the integrating factor plus c. And when I do that, I'm going to have y times, what's the integrating factor? 1 over x to the power of 10 equals the integral, what's q again? Minus 9 over x squared times, what is the integrating factor? We have it to be 1 over x to the power of 10, then plus c. So I have this y over x to the power of 10 equals, I think I can bring in my minus 9 out, equals x squared times x to the power of 10 will give me 1 over x to the power of 12 according to the law of indices, then plus c. Now the next thing I would do is to integrate 1 over x to the power of 12. But before I do that, I'll have this, at least for easy computation, x to the power minus 12 plus c. And if I integrate that particular expression, I'm going to have minus 9x to the power of minus 11 over minus 11 and plus c. Right, getting more interesting. So I have y over x to the power of 10 equals minus divided by minus is plus. So I'm going to have 9x to the power of minus 11 over 11 then plus c. So before I conclude, I need to get the value for c. But if you check the original question, they provided us with an initial condition that f of 1 equals 2. So all I need to do is go down. Then, since f of 1 is equals to 2, and I know that y is actually f of x, meaning that my x is 1 when y is 2. So I'll say when y equals 2, x is what? 1. So if I do that, I'm going to have 2 over 1 to the power of 10. I mean from this expression at the top here. 9 into bracket 1 raised to the power minus 11 over 11 plus c. And 1 to the power of 10 is 1, so I have just 2 here equals 9 over 11 plus c. And c becomes 2 minus 9 over 11. And c becomes 13 over 11 if you evaluate that. So I'm going to replace c to be 13 over 11 into this equation. Let me call it 4, into equation 4 here. And I'm going to get something of this nature. Y over x to the power of 10 equals 9x to the power of minus 11 over 11 plus 13 over 11. So now I'm going to cross multiply using x to the power of 10 to multiply the whole of this. So I have y equals x to the power of 10 into bracket 9x to the power of minus 11 over 11 plus 13 over 11. And if I expand that, I will have 9x to the power of minus 1 over 11, because x to the power of 10 and 11 will be 10 minus 11, that's minus 1, plus 13 over 11 x to the power of 10 if you expand this. So at the end of the day, I think the answer should be coming out. So y becomes, this is 9 over 11x if this comes down. According to the law of indices, 13 over 11 x to the power of 10. And that's the solution. Since we know that f of x is actually equals to y. So automatically, you can say that f of x, which is what we are looking for, is 9 over 11x plus 13 over 11 x to the power of 10. And that's the final solution. So when we go up and check, we can see that that corresponds to B. So that's how this question was actually solved. You can feel free to go back to the question again and go through it one after the other. I know I was very fast. That's because I didn't want the video to be very long. So that's why I was going that fast. But you can always go back and play the video, see the solutions again. You go at it one after the other. And you can use that to actually understand basically all that I've done so far. And if you have any question, you can just let me know in the comment section. Thank you very much, and God bless.